Chapter 11, asking and answering question about the difference between two population proportions. We start with section 11.1. What we have in this section is, before we talk about if you have a one populations, and you could always claim about the populations, and you find proportion of, let's say I want to find proportion of people with income more than $75,000. So you claim about one populations. So here we discuss about two populations, and we compare these two populations. So when you compare two populations, you either these two populations are, their proportions is equal, or proportion of one is greater than the other one, or less than the other population. But normally, since we always use greater than 0 or less than 0 or equal to 0 or not equal to 0, we find the difference of these two. So in this case, P1 minus P2 not equal to 0, or P1 minus P2 greater than 0, and P1 minus P2 is less than 0. So here, so there are two populations, and we want to make sure that these two populations are independent. They don't depend on each other. So as you know, each population has n and sample proportion. So we have n1 and p hat 1, n2 and p hat 2. Two samples are independent if selection of one individual that make up one sample does not influence selection of individual in the other samples. So when you take a sample from two independent populations. And then here, when comparing two populations on the basis of success proportion, it is common that we are using the difference between these two populations. So here, again, this is another definition we have. Only the case where two samples are independent samples is considered. Two samples are said to be independent if selection of one individual that make up one sample does not influence selection of the individual and the other samples. So this is one example. So in this example, there are talking about two populations. And first of all, when you want to work on the problems, you need to know whether before for one populations, we had to prove that N1P1 is greater than 10 and N1 1 minus P1 also is greater than or equal to 10. But here, since we have two population conditions, is N1P1 greater than 2 and N2P2 greater than or equal to 10, or N2 times 1 minus P2 is greater than 10. So condition, since you have two population, condition has additional calculations. So the formula for confidence interval is this. What we had before for one population, we had proportion of population is less than P hat plus E and P hat minus E. That's what we had for one population. What was E? E was margin of the error, which it was Z, and you had P times 1 minus P over standard deviation, N. Now, since we are dealing with two populations, the difference is between these two. Again, this margin of error is equal to this. How do I find the z? Normally, when you work on the problems, you normally have one of these three conditions. The confidence level given in the problem is 90%. In that case, z is 1.645. If confidence level is 95%, then z is 1.96. 99% is 2.58. So you take these values and you put it here for critical value or the z. And you already have P1, P2, and 1 and 2. And P hat 1, P hat number 2. Here also I show you how we come up with these values. Like when it's 90%, that means in case of two tails, you know the total area under the curve is always 1. So if I subtract 0.9 from 1 is 0.1, and divide this 0.1 by 2 is 0.05. 0.05 is area of each tail. Now, if you know the area to the left of this z, which is 0.05, and you want to find the z, if you want to use the TI-84 calculator, is second vars inverse norm. You put 0.05, and that gives you this number that they calculate here. The reason I'm giving you the calculation, just in case you have a number that is not here, it's 90, 95, 90. What if you have 98%? So here, for 95%, again, the total area under each curve is 0.95. You subtract that, is 1. You subtract 0.95 from 1. This is area of two tails, 0.05. Divide that by 2. Area of each tail is 0.025. Use the calculator and so on. Okay, so this is the calculation just for you to see that. But if you have a copy of this in front of you, you could always, you don't have to do the calculation. You could just pick the number from here. This is just in case, first of all, for you to understand where the number come from. Second, if you have a confidence level, which is not any of these three. So this is a formula that we use for confidence interval or difference of two populations. And there are 4 conditions on each problem. And if you want to understand it, you could just look at homework number 1. That question type is this estimation or hypothesis testing? It's always estimation. Is this when you are doing difference of population, is it sample data or experimental data? The answer is sample data. 1 variable or 2 category or numerical. 1 category or variable with 2 categories. How many samples of treatment? Always 2 samples, 1 from each population. Now, this is an example that there are 2 populations. One population is, in this example, you want to estimate the difference in the proportion of people aged 18 to 21 who think it's okay to use a cell phone in restaurant, and this proportion to those 30 to 49. So there are 2 populations. There is one that their age is 18 to 29. For those, we call it population number 1. Nx is given, so you could always find the proportion of the sample, which is x over n. Second group is age of 30 to 49 with this information. Confidence level also is given. So what we do is first we need to find P1 hat and P2 hat, which is x1 over n1, which like here is 354 over 708. So when you find that, then you could put it in the formula that I show you. You have everything here. How do I find the z? You understand that confidence level for 90%. What is confidence level for 90%? For 90% is 1.645. So you put that number here. And that gives you the confidence level. Now I'll show you how to use the calculator for that. To use the calculator, you go to TI-84, you go to stat, test, to proportion z interval, and then calculator would ask you to put x1, n1, x2, n2, and c level. Confidence level is 90%. And when you do that, you have the answers. Confidence interval. So this is how to use the calculator. This is how to take the numbers and plug into the formula. This is another example, very similar to that. There are two populations. Population number one is all the fathers, and population number two is mothers. Again, X1, N1, X2 is given. Construct the confidence interval. 95%. 95% is 1.96. Very similar to that one. You calculate P hat for each, put it in the formula, or you could use your calculator and find the confidence level. Very similar. So some examples in this homework are very similar to this. Some of them are very similar to that. This is another example that I got from one of our Professor Poway, example from her notes. Again, here there are two groups. People in sample of 258 cell phone user age 20 to 39. The other one 40, very similar to the other one I showed you, 40 to 49. So first of all, they ask you questions. You have estimation. Is a sample, is one categorical and two samples. And here, all these informations are given. So all you need to do is just take this and put into the computer. No, since the calculator need X1, sometimes if X1 is not given, see like in these problems, if proportion is given, if the proportion is given and N is given, then you could always calculate the X. For the, I think I have that on the next page. See here? So first you have to, when you want to do the problem, first you want to make sure that condition works. Like N1, P1, N1 times 1 minus P1, N2, P2, they all are greater than 10. You have to check that first before you actually do the problems. Then you calculate a P hat and P2, then put it in the formula. And this is how to use a calculator. So then I have the here for you the formula to use. I mean the problem, homework problem start from here. See, you always have estimation, you have the sample data, you have one categorical and two samples. These are the conditions that you always have for this kind of problems. So you always have these four conditions. Estimation, sample, one, two samples. Estimation, sample, two samples, and confidence interval, which I calculated here for you at the bottom. You can use in the calculator. Now, since the calculator requires X, if X is not given, see like in here, on this one, N is given, P hat is given, but not the X. So since you know P hat is X over N, if you cross multiply, X is 1600 times 0.115, which is 184. And also, that's how you could find X2. So in the problem, if X1 and X2 is not given and you want to use your calculator, since TI-84 calculator require X1 and N1 or X2 and N2, you could cross multiply N and P hat, these two are given, and find the X, and then put it in the formula. See, these problems are very similar. So we cross multiply to find X1 and X2 and put it in the formula. All right. You see, they all are very similar. I'll show you how to find X1 and X2 and how to use a calculator. I think it's easier to use a calculator for most of these problems. See, first you check the conditions, and then you find it. All problems are very, very similar. And you know, you want to read this, avoid some common mistake. Bring us to section 11.2. So section 11.2 now, what you want to do is you want to find about the claim. So the claim is always, we claim that proportions of two populations are equal, so the difference is 0. One is greater than the other one, the difference greater than 0. One is less, greater than. Remember, HO always take equality sign, but H1 can be one of these three. This is null hypothesis, this is alternate hypothesis. These are the claims. And this is opposite of that. HO is opposite. Sometimes it happens that equal to 0 is the original claim. But anyway, opposite of these three is always this one. So equal sign always is for HO. You don't use equal sign for claim for H1. We don't use it for H1. Here we need to find for test statistic. This is a formula. And again, you understand this when you work in the problems here. There are two populations in these examples, okay? One is representative sample of low-income adult, annual income less than 30. And in this case, there is also 65% that they would not buy electric car, and 59% responded the other way. So these two populations is P1 and P2. Here is the statement of the claim. Is there convincing evidence that proportion who would never consider buying an electric car is different? Means P1 is different and P2. See here, they're saying that P1 population of the first one is not equal to P2, it's different. When you say difference, means it's not equal to sign. So alternate hypothesis is this, and what is the opposite of that? Equal, which is HO. Okay, so this is your claim. This different, it helps you to understand that the claim is P1 not equal to P2. Okay, so first you determine your HO and HA. Alpha is given in the problems. So what I need to do here, again, I have to do the condition first, make sure that everything is greater than 10. Now, in the formula, what we are using is, let me bring the formula here so you can see it. To calculate test statistic, this is a formula. P1 hat, proportion of the sample of first population, proportion of sample of two. But here you have PC. PC, what is PC? PC is kind of average of all those. So this is a formula for PC. You have to calculate this first and plug into this 4. That's how to calculate, they call it test statistic, Z. To calculate the Z, you need to calculate this one first and then plug into the formula. So that's what we did here. So we separately, see, I put it here. N1 P1, which is you already have it here. You put that here. Plus N2 P2, which is this. You put that one here. Over N1 plus N2. What is N1 plus N2? Is 300 plus 300 is 600. So when you calculate that, you take that and you put it into that formula I'll show you. That gives you the Z value, okay? Now, when you find the Z value, that means in case of two tails, the area is, you want to find the area here, correct? And this Z is 1.50 or minus 1.50. To find the area, I show you how to use the calculator to find the area. Second vers normal CDF, Z1 and Z2. What is Z1 and Z2? Now, calculator require two endpoints. One endpoint is here, which we know is 1.5. What's the second endpoint? You have to arbitrary number. Arbitrary number is 10. So you put that number here in the calculator. So this is arbitrary number. Why? Because if you recall, the standard curve, the middle, which is the mean, is always 0, and Z1 is here, Z2 is here, Z3 is here. So when you go beyond 3, the graph almost is very, very close to this horizontal axis of Z. So when I say 10 here, means if you find between 0 and 10, this is 0.5, or if I have 1.5, 1.5 is this area. So if your area, if you want to calculate the area of this to the left, then you just put minus 10 and minus 1.5. That's why they're using that one there, okay? So you could either do it this way to find your number, and because it's 2 tails, we take this and multiply by 2 to give you this one, okay? So that would be your p-value. Now, if the p-value, we had this before, if p-value is greater than alpha, remember, if p-value is greater than alpha, then you do not reject HO. Basically, you accept HO. If p-value is less than alpha, then you reject HO. We can also find the p-value through the calculator. Alpha is given, is 0.05, is given in the problem. P-value, you could either do the calculation or find it through the calculator. If you want to find the p through the calculation, that's how to do the calculation. You find this and you multiply by 2 is 0.1336, right? But if you use the calculator, then this is what you have. On the calculator, you go to stat, test 2, proportion Z test, you put all these numbers, and they ask you whether it's less, greater, or not equal. That is, this symbol that we use here is always a symbol that we use for H1, okay? So that give you the p-value. So you find the p-value, which p-value here is very similar to what you have here, okay? So all these problems that you have here is just all following the same format. If you use the calculator, if they all use the same format, so let me go through all these. I think they all are following the same format. This is another one I show you here. So here you need to find, again, N1, P1, purpose Z test. See, when you use the calculator, and you put all the numbers, they give you one of these 3. Which one of these 3 you have to pick? The symbol that you use here has to be a symbol of HA, whatever HA is, okay? So in this is example number 4. In this one, HA is less than 0. We always use the symbol of HA for calculator at the end when they're asking which one of these 3. You are using it here. Okay, so that would give you the value. Or if you want to use the calculator to find the p-value, but when you do it this way, the calculator would find the p-value for you. So this is the hand calculations, and this is how to use the calculator. This is how to use the calculator to do that. Another one. The values are given. See, at the end, the calculator would give you the Z. You could compare that with Z of the calculation. That if you want to verify the number that you did through the hand calculations, the calculator would give you that. Calculator also would give you the p-value. This is a p-value you find through the calculator, which is 0.0006. Here they did hand calculations through the second verse. They find it through the second verse. But you don't have to do that if you use the calculator. The calculator will give you the value of p. See, the p-value, which is 0.006, is less than alpha. So then what? We reject HO. Okay. So that would be section 11.1 and 11.2.